Oh, I think I finally cracked it. I mean, look at this back test. The Sharpe ratio is it's off the charts. The equity curve is a thing of beauty. I'm telling you, I am ready to put real money on this thing. Whoa, hold on a second. Look, that equity curve is impressive, I'll give you that. And believe me, that's the kind of result we are all chasing. But before you go and bet the farm, let me ask you something, a really critical question.
Why is it that almost all of these picture-perfect backtests just completely fall apart the second they touch real money? I'll tell you why. It's because what you've likely found isn't real alpha. It's a ghost in the machine. A ghost? What are you talking about? This backtest is built on solid historical data. The numbers are right there. How can they be wrong? And that's the classic trap. It's exactly why so many funds fail. The numbers look solid, sure, but they are hiding a very big secret. Let's pull back the curtain on this.
This is a quote, word for word, from Marcos López de Prado, who is arguably one of the most important minds in financial machine learning today. And notice, he's not saying some discoveries are false, he's saying most. We're talking about a massive crisis of selection bias and overfitting. It's the hidden reason all these promising strategies end up blowing up.
Wait, most are false? How is that even possible? So you're telling me my beautiful backtest is probably a lie?
It's worse than just being wrong. In a way, it's actively lying to you. And this, right here, is the biggest lie in all of quantitative finance. We've all been taught to use backtesting as our main research tool, right? To go hunt for profitable strategies? That is the fundamental mistake. But how else are you supposed to find out if an idea actually has an edge?
Right, and López de Prado is incredibly clear about this. A backtest is just a sanity check you run after you've done the real work. Using it as your main discovery tool is what he calls drink driving. You are almost guaranteed to crash and burn. The real research is about finding features that have genuine predictive power before you even think about running a backtest. It's about knowing why something should work, not just that it happened to work on one random path through history.
Okay. I get overfitting as a concept. But what's so different about financial data? I mean, machine learning is amazing for recognizing cats in pictures or translating languages. Why does it just break when it comes to finance? Quant expert. That is the million-dollar question. And it's because standard machine learning makes a huge assumption that your data points are all independent and identically distributed. Well, in finance, they're not at all. Everything is connected through time, and this creates a really subtle but absolutely deadly problem called data leakage.
So, have a look at this. This visual shows a totally standard machine learning technique called k-fold cross-validation. You basically chop up your data, you train your model on some of the pieces, and you test it on another piece. For recognizing images, this works perfectly fine. But in finance, it's a total disaster. Just imagine your label is based on a 20-day forward return. Well, information from the end of one of your training chunks can easily overlap with the information at the start of your test chunk. Your model is literally getting a sneak peek of the future. It's like letting a student glance at the answer key right before a big exam.
That's insane. So my model isn't some genius predictor, it's just a cheater. And this means, my gosh, that countless quant strategies might have failed not because the core idea was bad, but because the way we tested them was fundamentally broken from the get-go? Exactly. It's not a prediction at that point, it's a memory. But here's the good news. This is a solvable problem. See, López de Prado didn't just point out the problem and walk away. He actually built the tools to fix it. And this isn't some abstract theoretical stuff. This is a practical, hands-on toolkit for building robust financial AI that actually stands a chance in the real world.
This slide shows the solution perfectly. On the one side, you've got the old, leaky method. But the main graphic shows the fix. It's called purged and embargoed cross-validation. So first, you purge any of the training data that could possibly contain information from your test period. Then you add an embargo, which is really just a small gap, to create a clean break in time. This is how you guarantee your model is being tested on data it has truly never seen before.
Okay, next up, we have to fix the actual question we're asking the model. Instead of just asking it to predict up or down, which is way too simple for financial markets, the triple barrier method labels the outcomes the way a real trader thinks. Did the trade hit your profit target? Yep. Did it hit your stop loss? Nope. Or did it just meander around and expire without doing either? This creates much richer, way more realistic labels for the model to learn from.
Wow, okay. So I'm seeing it now. These aren't just a few separate tricks. It's a whole connected system. You use the triple barrier to create smarter labels, and then you use the purged cross-validation to test them without letting the model cheat. So what does the whole workflow look like when you put it all together?
You've got it. It's a completely new way of thinking, from start to finish. Let's lay it out.
Here it is. Step 1. You've got your primary model. Let's say it's a simple momentum strategy that predicts the side of the bet, long or short. Step 2, you use that triple barrier method we just talked about to label the outcomes of those predictions. But Step 3 is the real game changer. It's called meta-labeling. Meta-labeling. That sounds really powerful. I mean, deciding if I should even place a bet seems every bit as important as deciding which direction to bet on.
Oh, it's more important. It's maybe the most important piece. This concept brilliantly separates the question of what to bet on from the question of when or even if you should bet at all.
So think of it like this. You have two models working together. The first one is what we call a high recall model. Its only job is to cast a wide net and find every potential opportunity, even if that means it gets a lot of things wrong, a lot of false positives. Then you train a second meta model. Its only job is to look at the predictions from that first model and decide, hey, is this one any good? It learns to filter out all the noise and gives you a confidence score on whether you should actually place the bet or just pass.
Yeah, to put it simply, your first model finds the direction of the trade. Your second, meta-label model, determines the size of your bet. It basically functions like a machine-learned version of the Kelly criterion, telling you exactly how much you should risk based on its confidence in that specific prediction. This is a massive, massive leap forward for risk management.
Okay, you've convinced me. I'm sold. This honestly feels like the key to survival. As markets get more efficient and all the simple algos get crowded out, having a robust process like this seems like it's the only real defensible edge left. So how can I actually start applying this stuff today? All right, here are the 3 things you need to start doing right now. First, always purge and embargo your data to prevent leakage. Every single time, no exceptions. Second, use meta-labeling to decide your bet size. Do not rely on your primary model for that. And third, and this is the best part, you can start today. You don't have to code all this from scratch. There are open source libraries like ML FinLab that have already implemented these exact tools for you.
And I want to be really clear about this. This is not some fringe academic theory. This is the exact material that López de Prado himself teaches in his graduate course at Cornell University, RE 5256. This is the new gold standard.
So you're saying this is literally what the next generation of top quants are learning right now?
It is, and that's exactly where we're going next with this. Today was just the high-level flyover, but starting next week, we are launching a full series where we break down the actual lectures from that Cornell course one by one.
So if you really want to learn the framework that's being taught to the next generation of elite quants, this is your chance. Make sure you subscribe so you don't miss that first lecture.
We'll see you then.